Hi, in this video I'm going to show you how the multiplicity of the roots differ the graph of a polynomial. Okay, so let's take one example here. This is a polynomial of degree. The total degree is 3, right? Because it has degree 1, exponent is 1. After you FOIL it, you will get exponent 2, that will be degree 2, and since you multiply, you will get degree 3, right? Because since this you multiply the factors, you add the degrees, so the total degree will be 3. So let me graph this function using calculator. I saw this graph. So what are the roots basically? So how to find the roots? You set this equals to 0, you will get root is 1, and if you set this equals to 0, you will get root is -2. And if you graph this function, so you will get this graph. Okay, if you in your calculator, if you enter like y equals to 3x minus 1 times and then x plus 2 whole square, you will get this graph. Okay, here the root 1 has multiplicity 1 and the root -2 has multiplicity 2. Now let me list those roots. X equals to 1 and -2. What is the multiplicity of x equals to 1? What is the exponent of that factor? It is 1. So it is odd multiplicity, right? This factor though has exponent 2, so the root -2 has multiplicity 2, so it is even multiplicity. Look at in the graph. If a root has even multiplicity, then the graph was below x-axis. Left to the root, the graph is below x-axis, and right to the root, also graph is below x-axis, meaning that the graph will stay same side of x-axis. Okay, either if it is both side will be below x-axis or both side will be above x-axis. So but if the multiplicity is odd, then the graph will cross, meaning that the left part the graph was below x-axis, on the right part the graph is above x-axis. Did you see that? So here you can say that if the multiplicity is odd, then the graph crosses x-axis at that root, at this root. Okay, but if the multiplicity is even, the graph just touches x-axis at that root. It does not cross, it just touches x-axis at that root. All right, so this is how we decide whether a graph touches or crosses x-axis at the root. If the root has odd multiplicity, then the graph crosses x-axis at that root, and if the root has even multiplicity, then the graph only touches x-axis at that root. So let me talk about this example. So let's find out the solution of this. Find the roots of x cubed times fx equals to x cubed times x minus 1 squared and then 2x plus 3. So how do I find the root? You set each of the root equals to 0, right? X cubed equals to 0, meaning x equals to 0 is one of the root, and then x minus 1 squared equals to 0, meaning x minus 1 equals to 0 if you take the square root on both sides. So you get x equals to 1 if you add 1 on both sides. So this is the second root. And how about the third root? So the next factor is 2x plus 3 equals to 0, right? And then subtract 3 on both sides, you get 2x equals to -3 and divide by 2 on both sides. So you get x equals to -3/2. So this is the third root. Okay, now we need to find the multiplicity to decide whether the graph touches or crosses x-axis. At those roots we need to find the multiplicity. Let's make a table, root and multiplicities. Okay, so what are the roots? 0, 1, -3/2. So what are the multiplicities? 0 has multiplicity 3, right? It is repeated 3 times. 1 has multiplicity 2, and then -3/2 has multiplicity 1, because the exponent is 1 here, exponent is 2 here. So is it odd or even? It is odd. It is even, and it is odd. So at the odd multiplicities, at the root of odd multiplicity, the graph always crosses x-axis. So the cross x-axis, At the even multiplicity, the graph touches x-axis, and at the odd multiplicity again crosses x-axis. So this is how we determine in which root the graph touches or crosses x-axis. Okay, thank you guys.